It's my great pleasure to introduce Professor Carol Robinson. In preparing this introduction, I learned a lot about Carol, largely because she wrote this for me. And it was all sorts of things I could never have found out independently. I thought I was going to focus on her stellar academic career and all the hundreds of publications, etc., but that's actually not the focus she chose. But Carol's PhD was in public health engineering, isolating the methane-producing microbes from marine sediments to help treatment of high salt-containing industrial wastewaters. For her second postdoc, she moved out of the sediment and into the surface ocean to study the balance between phytoplankton uptake of CO2 and bacterial production of CO2. Her major hobby at this time was scuba diving, which she funded by teaching diving at a dive school as often as possible. She also tried her best to include diving in her scientific research, including diving under sea ice in the Antarctic to measure bacterial respiration, and diving on a hydrothermal vent in the Aegean Sea to study the effect of increased CO2 on plankton primary production and respiration. After working for 10 years at a research institute in the UK, she moved to academia in order to have more interaction with early career scientists, and is now a professor at the University of East Anglia in the UK. She teaches biological and chemical oceanography, including a marine sciences field course to undergraduates, and created an annual weekend course, Introduction to Oceanography for Divers, for the general public. Her research involves spending extended times at sea or on Antarctic bases, sometimes as the principal scientist, and she's fascinated with aspects of human behavior, involved in working and managing teams. And this is something I had no idea about. And last month, she submitted her master's thesis on how we teach students and how to reflect and learn from their mistakes. Carol is my boss, so that's somewhat intimidating, but I have no idea how she finds the time for all of that. Her current hobby is learning to sail, which actually means, according to her, 2 years of mending and cleaning, and very little days of actually sailing. Carol is the chair of IMBeR, and she has been for 3 years, and she's been with IMBeR basically since its inception, when it was actually called Oceans. She didn't include very modestly, she didn't include that she's a fellow of the Royal Society of Biology and the past president of the Challenger Society of Marine Science. And as I said, Carol's my boss. She's a pleasure to work with, and over to Carol.
Thank you so much, John, and it's actually a real pleasure to work with you too. Thank you so much to your team, the dream team who have organized this awesome conference. So this is the last... It's me. I have this aura around me that breaks everything. So this is the last, the final lecture of the conference. Thank you very much for staying around till the end. And I'd like to use this time really to highlight the breadth of science within IMBeR, conducted within our regional programs, our working groups, and our endorsed projects, and also facilitated through workshops, symposia, and conferences such as this one. I'll try to use these highlights to review how far we've progressed in achieving the challenges we set ourselves in 2016. And I'll also identify areas of research that still need to be progressed, priority gaps in our knowledge, including those that were mentioned by our keynote speakers this week. And then I'll finish by considering what IMBeR should do next in order to progress our vision of ocean sustainability under global change for the benefit of society, and to emphasize some of the ways in which you can all get involved in co-producing or co-achieving this vision. So let's remind ourselves about our grand challenges. The first is to understand and quantify the state and variability of marine ecosystems. The second is to take that understanding into models in order to predict and project future scenarios. And the third is to improve and achieve sustainable ocean governance and our interaction, science, policy, and society. But all of this is aiming towards actually making a difference, actually transitioning to sustainable oceans. So we need to show that our science has impact, that it's actually used, it's accessible and useful in policy and governance, that it affects a change in behavior, that we increase ocean literacy, and that importantly we build a community of scientists who can work at this, in this space. So I mentioned on Monday, way back on Monday, that IMBeR has 4 regional programs. It has a number of working groups. We have a number of endorsed projects in more than 80 countries. We have the amazing Early Career Network, so that at any one time, something like 2,000 scientists can be working towards our science plan. So I can see you all sitting here thinking, oh my goodness, how long is this going to last? So I think you'll be very relieved that I've set myself some time and space scales. So when I say past, I mean in the past 2 years. So think about that. All of this science that I'm going to show you now has come out in the last couple of years. My present is this week. So things that I've picked up and talked to people who are here this week. And my future is to 2025. That's the time horizon I'm thinking of in terms of our science plan. So let's first of all think about Grand Challenge 1. So those of you who've written a proposal will know that by talking about something as interconnected and integrated as marine systems, when you write a proposal, you almost take away that integration because you have to silo things into objectives that reviewers can take into consideration. So within that constraint, I've pulled apart our science and tried to allocate it to a grand challenge, but you'll have to realize that that's a bit of a construct, and actually all of these grand challenges integrate with each other. So what are the respective effects, impacts, and mechanisms of natural climate variability and anthropogenic global change on marine biogeochemical cycles, ecosystems, and human well-being and livelihood? And when the science plan was written, obviously we needed an aim, we needed a driver. Where do we want to go to? What are the knowledge gaps? So at that time, we suggested that the knowledge gaps included that we needed a better integrated observing and modeling system that spanned the whole social ecological scale, that we needed to better understand the scales over which non-climate stresses such as fishing interacted with climate change and marine ecosystems, and we also needed to quantify and understand much better the interdependencies between human systems and marine ecosystems, moving away from simply thinking about fisheries. So I've picked some of the work, as I say, that's been done over the last couple of years to try and point towards how we're moving towards our knowledge gaps. So this is some research that was done within the IMBeR regional program IMBeR, Sustained Indian Ocean Biogeochemistry and Ecosystem Research Project. And a major remit or a major focus of IMBeR is the second International Indian Ocean Expedition. And the first synthesis paper that has come out of that expedition and that remit to look at how geologic, oceanic, atmospheric factors interact in the Indian Ocean to create the unique dynamics and how that affects marine ecosystems and human populations. The first synthesis paper came out in 2017, led by Raleigh Hood and his group. And this was looking at how the interaction between the seasonal reversing southwest monsoon, which creates high productivity and upwelling, how that interacts with the reversal of a northwest monsoon, which tends to form downwelling. And what they found was when they looked at how the dynamics were changing and how the behavior of the food webs were changing, they could see a real change in behavior of zooplankton in terms of their vertical migration and in the feeding of large pelagic fish. So a study that is beginning to look at how the dynamics of the environment is actually affecting food webs. And just in March this year, there's been a deep sea research special issue looking at studies from the Indian Ocean. So a couple of studies that scientists within ICE have been doing. You'll all know that working in the poles is very difficult, that the data is very sparse. And one way to get around this, perhaps, is to use tags that are on seals. And these tags can measure temperature, salinity, oxygen. But one problem with these tags is that they have an offset, that they have a bias or a drift. And one of the studies that iScience have done is restrained this offset. So they've improved the precision of the measurements of salinity by something like tenfold. And this means that they can now use this salinity data to measure when the salt is extruded or ejected from the ice. So they now have a much better understanding of when during the year the ice actually melts and forms again. So through improvements in the precision of data has made a big change in our understanding of the seasonality of the Antarctic. And then I simply had to put this in. Can you imagine being able to detect whales from space? So this is a study where they've used images to be able to detect and identify 4 different types of whale: humpback, southern right, fin, and one other that I've forgotten, I think a grey whale. And they use this by the change in the coloration of the whale against the water, their position, their body position, the blow, and also the trail of poo that the whales create. So I simply had to have whale poo in my lecture. So it's really important for us to be able to determine the status and the trend of biodiversity in the marine system. And there are 2 synergistic methods of doing this. One that is developed through GOOSE, the Global Ocean Observing System, where they look at essential ocean variables, and one that's been developed through IMBeR and GeoBORN, which looks at essential biodiversity variables. And this is a study by Frank Muller-Kaja, who's conceptually shown how these 2 independent but integrating systems are connected. And of course, being able to measure a standardized measurement or a determination of the state of the variability and the state of the ocean really helps underpin IPCC and IMBeR's reports. And I also wanted to mention that IMBeR works really closely with the Global Ocean Observing System. So our Southern Ocean Regional Program, ICED, is closely linked with SOOS, the Southern Ocean Observing System. CyBER, our Indian Ocean Regional Program, is actually co-sponsored by Indian Ocean Goose. And scientists from ClearTop, our Climate Impacts on Top Predator Regional Program, have contributed to the science plan of Mongoose, which is the Mediterranean Ocean Network Global Ocean Observing System. So IMBeR is closely interacting with creating the wherewithal to measure the biodiversity and actually to standardize how we define the biodiversity. But we're also using this information to look at how changes in the environment affect this distribution or biodiversity. So this is a paper recently published by Angus Atkinson, which looks at the abundance of krill in the Southern Ocean and how that's changed over the last 90 years. And they've been able to see that the krill abundance in different places has increased or decreased over this time, that there's been a mean increase in body length, which perhaps reflects reduced recruitment. And this reduced recruitment has been linked to warm, windy, cloudy weather with reduced sea ice, all of which you think might affect the egg production and the recruitment or retention of the juveniles. And this change in distribution, so the hotspots of abundance changing to somewhere else further south, closer to the Antarctic shelves, has obviously perturbed the krill-centered food web, and this, of course, challenges our way that we can manage this really important ecosystem. IMBeR, together with SOLAS, are part of an ocean acidification working group run from the International Coordination Office in Monaco. And this is a really important working group that works on standardizing our methodology for reporting ocean acidification and creating action plans for countries around the world for how they might monitor changes in pH and carbon dioxide in the coasts. So a study also from ICED looked at the regions within the Southern Ocean which have potential highest growth of krill, and they used an empirical relationship of growth rate of krill. And what they were trying to find out is where were the hotspots of potential growth of krill? Where are the areas that are needed most to be conserved? And they found that the potential for growth region was restricted to only 3 areas. And that, so these were in the Scotia Sea near South Georgia, along the Antarctic Peninsula, and also in the Ross Sea. And particularly for the larger krill, which presumably need more food, more energy, their regions in which they are preferentially able to grow is very restricted. And this information is really important for projections, so that if we're deriving management policy from one region of the Southern Ocean, we need to be aware that actually the seasonal and the regional variability would have a big impact on our management plans. And of course, growth, the potential for growth is not necessarily the same as abundance, because as well as needing the supply of phytoplankton food and the seasonality in the ice, the krill also need deep water for spawning and egg production, and they also need shallow water to retain the krill within the seasonal ice zone. So a study that's linking seasonality, environmental parameters, and empirical relationships of growth in order to better be able to manage this important food resource. And of course, on Monday, we heard from Alistair, who talked about a stable isotope study by Pethybridge et al., who were able to look at the length of the food chain, so the complexity of the food chain and how that was related to the environment. And this is just one of their results where they showed that the food chain was affected by the oxygen concentration in the mesopelagic layer, which has implications for how these food chains might change in lower oxygen, deoxygenated waters. We also had an interesting talk from Lynn Shannon on Tuesday, who showcased the work of Kelly Ortega Cisneros, apologies if that's pronounced incorrectly, who looked at the interactions between the upwelling, the primary production, and the fisheries, and how some of these stresses can be synergistically and antagonistically or additively integrated. And of course, we also learned that not always does 5 + 5 = 10. So Grand Challenge 1 then, we were trying to understand and quantify the state and variability of marine ecosystems. These were the knowledge gaps that we thought existed in 2015. So where are we progressing towards closing these knowledge gaps, and what are our next steps? Well, just with data collected and published within the last 2 years, I think you can see that we're moving along the spectrum to be able to integrate observing and modeling systems, but that we haven't yet quite got to including the whole social ecological system. I think the scales over which non-climate stresses interact is worked upon by Lynn and her colleagues, but I'm sure there are regional and global scale issues that we still need to address. And these interdependencies between human systems and marine ecosystem beyond fisheries, I think this is still a goal that we still need to progress towards. So that wasn't me. So our experts gave their feedback on the next steps. What are the crucial our knowledge gaps that are impeding progress? And they told us that we needed to think about new technologies, that we needed to have better data collection efficiency, that we needed particularly to think about how we were detecting and tracking changes in the marine ecosystems, that we needed to use multiple and comparative modeling approaches, and expand the use of models really to include industries, governance, and society. Alistair also stressed the importance of incorporating climate change into all of our assessment and management decisions, that we needed new ways of disseminating information and communicating information to know better about the combined effects of multiple drivers, that we need to really bring on board data from and information and the perspectives of industry and management, and have increased effort to think about how we can mitigate the negative effects of ocean drivers. So all really good pointers of the next steps. Where should the community, including IMBeR, go next? So let's try and do the same thing with Grand Challenge 2. Here we're trying to take this understanding of variability and quantifying ecosystem state into improving scenarios, predictions, and projections of future ocean human systems. And here you can see that the overarching aim is to understand the interdisciplinary understanding that's needed to improve these models. And again, we had a driver. What are our knowledge gaps that we thought existed in 2015? And here we thought it was important that we needed to identify the critical linkages between food webs, biogeochemical cycles, and human well-being and livelihoods. These needed to be incorporated into models. And we also needed to address approaches that combine global and regional models in order to have specific regional information strongly impacting our global perspective. So what are the things that we've been doing in the past couple of years in terms of progressing towards these model ambitions? Well, one of the things that we've been doing, Eric Galbraith and Laurent Bopp co-chaired a special session at our IMBeR in Woods Hole in 2017 on critical constraints. And what a major output of that workshop has been is a creation of a field guide, if you like, of data that's accessible to anyone in order to drive, constrain, or evaluate models. And this was launched on Thursday at 5 o'clock, I think. Was anyone at the launch? Ooh, did the launch happen? Am I dreaming? Oh, okay, so it may have been launched, but it will be launched if it hasn't already. So Laurent sent me some slides from this amazing Open Hub website, which gives you information on the external drivers, on the physical parameters, the biogeochemical and ecological parameters, as well as actually the sociological parameters. And this is just an example of biogeochemistry, so you're able to look at ocean color, and the products and the data are all the data is all there, so you understand what has been done to the data to create these products. We have surface ocean CO2 from the SOCAT Atlas. The version 9, I think, was released yesterday or the day before. And we also have World Ocean Atlas data for things like temperature, chlorophyll, and salinity and primary production. So a really valuable resource for anyone to use that's an output from our IMBeR 2 years ago. You also heard from Eric and Laurent, who talked about the real importance of comparing models, that given the same input parameters that the models can run in, you can compare their output and help you to constrain their projections. So Eric told us about FishMIP, the intercomparison of fish-related models, and of course, Laurent and Eric are both involved in CMIP, the Coupled Model Intercomparison project. One of the studies that scientists within ICED regional program have been doing is a collaboration between climate scientists and ecologists. So it's really important in terms of food web predictions to know the seasonal cycle of the ice. This has a big impact on the habitat and the food source of the food webs. But of course, the models all give slightly different answers, and the ecologists try to explain to the climate scientists that by having this range of outputs, it really propagates and creates a very wide deviation between the predictions of how the food web and the ecology changes. So the scientists looked at 35 different IPCC class models that were in the Model Intercomparison Project 5. And they were able to collect a subset of these models so that they could improve the prediction of sea ice extent by a third, by 30%. And this really improves the ecological interpretation if you really know the seasonality and the extent of the sea ice. So that is a really important collaboration between the ecologists who needed a more constrained information about sea ice and the climate scientists who are giving excellent projections of how the sea ice will change. This is work from the Cleartop Regional Programme undertaken by Olivier Moret and colleagues. And what he was doing was creating so-called oceanic system pathways. So just as we have policy-relevant pathways of climate change for IPCC, so the RCPs that you all know about, the business as usual and the doubling of carbon dioxide in the atmosphere, he has created system pathways that look at different priorities for decisions. So do we want an ocean that's more sustainable? Do we want to prioritize technology and use of fossil fuel? Do we want business as usual or our current convention? And these oceanic pathways have been accepted as the basis on which the fish MIP comparisons are done. So this is a really important contribution of human behavior, human decisions in these scenario testing in the context of IPCC and IMBeRs. So in knowing that we had these knowledge gaps in our bringing in information about humans and marine ecosystems into our projections and predictions, Eugene Murphy and Laurent Bopp, with colleagues, set up this session this week, Ecological Feedbacks in the Earth System, really to try to understand how the physical, chemical, and biological systems interact with each other. And they asked these 4 questions during the session this week, which was very well attended, and they feel has progressed the science to the extent that they're beginning to talk about papers. So this is a mechanism that we've actually taken a knowledge gap, brought it to this conference, and have discussed and progressed in our understanding of the things that were preventing us to progress. So Grand Challenge 2 then, improving scenarios, predictions, and projections. Our knowledge gaps, remember, were identifying critical linkages between food webs, biogeochemical cycles, and humans, and also investigating approaches for combining global and regional models. So in the work that's just been presented over the last 2 years, I think you can see that we're beginning to interact the food webs with the biogeochemical cycles, and there's beginning to be human conceptual information, but the human well-being and livelihoods is not yet in our whole system models. So what did our experts say were our next steps? Well, they suggested that we needed to really understand the differences between the models and to constrain these projections. So these intercomparison projects are incredibly important. Both of them actually said, well, okay, we accept that our models are quite simple and we need to begin to make them more complex. We need to decide which of the processes, biological and microbial processes, that we incorporate next. And we also have to think about surprises, things, unknown unknowns or known potential unknowns, and move from projections to predictions. So the thing that's important to a lot of people is the prediction of what's going to happen on the 5 to 10 year timescale, and not necessarily the 50 to 100 year timescale. The community are feeling more comfortable in climate change scenarios, but they need to also begin to incorporate fisheries, habitat loss, pollution, geoengineering, ... So they see that by constraining the information that they have now, they're in a more comfortable position to include more biological parameters and interactions. Definitely need to get humans into the marine ecosystem. The marine ecosystem includes humans. And Eric gave a really nice presentation about the beginning of potential to integrate quantitative non-monetary measures of human relevance. So remember, he asked us about how do we feel, how happy do we feel, how do we put that well-being and happiness and job satisfaction into our models. Okay, then, now I'm moving to Grand Challenge 3, and now we're trying to improve and achieve sustainable ocean governance. Our overarching question was, how can we improve communication and understanding between our science, policy, and society to achieve better governance, adaptation to, and mitigation of global change, and therefore transition towards ocean sustainability? Again, we realized that there were some knowledge gaps that perhaps we should try to tackle first. So we wanted to try to identify the spatial and temporal scales of human responses to local, regional, and global marine change. We wanted to explore the effects of alternative or adaptive management responses and governance systems on human-related risk exposure and impacts. And we also thought that it was important to quantify the differences in the local versus distant fisheries on human societies and sustainability. So I should say that in the last, this science plan, which started in 2016, and the previous science plan, which started in 2005, this is the Grand Challenge that has made the greatest jump in integrating human dimensions into marine ecosystems. And we owe that to a large part to our Human Dimensions Working Group, which was led by Alida Bundy and currently led by Ingrid van Putten. So this has made, I think, the most significant improvement in the way that biogeochemists, ecologists actually interact and become more interdisciplinary. So what is the interdisciplinary type work that's been occurring? This is a project that was funded by the Belmont Forum and part of the ESAS, Ecosystem Studies of Subarctic and Arctic Seas. And they were looking at the resilience and adaptive capacity of Arctic marine systems under changing climate. And this involved having a number of stakeholder workshops in the 3 countries that were contributing to this project, Japan, Alaska, and Norway. And they aimed to synthesize impacts of climate change on marine systems and the implications of that on fisheries, coastal communities, and management, to evaluate the ability of scientific and management institutions to adapt, and also to explore ways to improve resilience. In this, this balance between trying to feed a growing global population and trying to conserve our marine resources, it's always important to look at new ways of trying to value marine biodiversity. And one potential way, is to actually value ecosystem services and biodiversity in terms of money and in terms of other values. So this was a study undertaken by Rachel Kavanagh from ICED Regional Programme. And what she did was she compared 3 contrasting systems, the tropical Pacific, the Southern Ocean, and the UK coastal systems, just to see how valuation might be a way of conserving and balancing food production and conservation. And one of the things that she found was that valuation can be useful in certain circumstances, but in order to value an ecosystem, you really need a lot of ecological information to be able to balance or prioritize the value. And this was very clearly not there yet. So in order to progress with value, we really need more ecological information. And she proposes, or the team proposes, that actually it's really important to incorporate this economic value of biodiversity into mainstream decision making. And I know there have been a number of presentations on socioeconomics and valuing ecosystem services this week. So the work of ICED and their collaboration and contribution to the Commission for the Conservation of Antarctic Marine Living Resources, CAMLR, in the Southern Ocean, is making sure that the science that's undertaken within ICE is accessible and relevant to the CAMLR policy and management decisions. And they also work with the Committee on Environmental Protection and the International Whaling Commission. So they do this by membership of committees and co-producing, co-designing the information, the type of information that the decision makers, the policy makers require. So really important to have this stakeholder engagement. Benjamin Planck from the Ecosystem Studies of Subarctic and Arctic Seas has written recently a very nice paper. I love this paper on a participatory scenario method to explore the future of marine social ecological systems. So the idea is to talk to the local people, the people that are affected by fishing, and have them imagine a scenario. What would happen if the local small-scale fisheries were actually reduced because of more industrialization and a larger conglomeration to come along and be the major industrial fishery? What might happen in a climate change scenario where the ice melts and the fisheries biomass goes down? And they found that this participatory scenario method was a venue by which everyone who had an interest and a stakeholder position on the environment and the fisheries and the use of the marine system were able to think about, what would happen if this happened? How would I feel? How would this affect me? And by taking 4 scenarios through this process, they found that there was much more participation, there was much more conversation. And by starting with simple scenarios that contrasted with each other, they were also then able to integrate these scenarios. So what if this happens as well as this happens? What then impact will that have? So this was a really important way forward in order to explore how people feel and how people value the marine environment. This was also a recent paper by Prateep and Derek Armitage, and this looked at how we might understand how social regime shifts in coastal systems occur. So we know about ecological-based, perhaps, regime shifts in systems, but how is the integrative social ecological system expected to change when something very dramatic changes? So a change in shrimp farming, for example, aquaculture. So this was a study with 2 case studies. They looked at coastal lagoons in Vietnam and India and outlined how this could impact and how it had impacted the various uses of the coast, the lagoon. So they identified 6 core dimensions of these socio-ecological regime shifts and proposed a framework by which they could be studied and governed in the future. So I've already said that Grand Challenge 3 is perhaps the newest of the Grand Challenges within the IMBeR science plan. So the group of people who work towards the Human Dimensions Working Group and the Grand Challenge met for the first time in 2017, and they set up some activities to occur at the SSC meeting in 2018. So they introduced all the biogeochemists and the physical oceanographers to cafe worlds or world cafes. So I think you can see that just as we need to communicate and build teams with scientists, policymakers, fisheries managers, general public, we also had to actually build a team within the scientists. And part of the activities that emerged from last year's Scientific Steering Committee and this team building was to create some special sessions that would occur this week. So this week it was a focus of the activities that we wanted to progress the work within Grand Challenge 3. So there were 3 special sessions that came out of these discussions. One was co-chaired by representatives of IMBeR, the research project Earth System Governance, the research project Future Earth Coasts, and the Ocean Knowledge Action Network. And this was the World Cafes that were undertaken under the banner of Marine Governance, Challenges for Sustainability. And this was a really well attended and a productive session, such that they're discussing now articles to be published in Coastal Management is planned. The next session that arose out of discussions at our Scientific Steering Committee last year was one called Designing the Quilt of Sustainable Oceans Governance. And this was convened by Rob Stevenson, Chris Vitanovich, Alistair Hobday, and probably others. And they explored similarities and differences in approaches. So there was a discussion about the definitions of the different approaches. They concluded that there's a need for synthesis and further comparison of these concepts. And they were also suggesting a future IMBeR activity, a workshop to progress this. And finally, the third special session was organized by the Dream Team, these 3 superheroes, Chris, Ingrid, and Mark Dickey-Collis, and they asked, but why won't they use our science? And here I learned about bright spots and optimism. I learned about the reflections, the perspective of an end user, and I also learned about how important communication, human behavior, team building, collaboration, all the things I love doing, and of course transparency are really important in this interdisciplinary science space. So we heard from Ingrid, one of our keynote speakers, on the importance of thinking about psychology and behavior in trade-off decisions. Remember, she gave us some little tests about what we thought about national cultural perspectives. Were we highly avoiding ambiguity? Do we need all of the information there first before we can actually progress? Or are we more laid back, flexible, adaptable, and willing to jump in and start something without all of the information there? So she made us think about our own personality and our natural cultural characteristics and how this feeds into how we interact and work with each other. We also had a great keynote from Derek, who gave us the ingredients of governance, in particular talking about knowledge co-production. And he made us think about all of these impediments or challenges to knowledge co-production and basically say that actually where there's a will there's a way, that we can actually overcome any infrastructural impediments. So doing knowledge co-production is not a threat or should not be a threat to fundamental science. It is absolutely amazing for early career researchers, and a lovely paper by Rachel Kelly and colleagues in Brest all about how to develop the next generation of interdisciplinary scientists and researchers. And something that I also was interested in is how do we go about measuring success? So this is something that we are talking about within IMBeR. We can collect metrics of the number of participants in the conference. We can get feedback on whether people felt that it enabled them to collaborate or to write a new research proposal. But how do we continually reflect on how we're doing in order to improve? We discussed this excellent paper by, is it Mary Evans and Chris Vitanovich, which really looks at the policy impact and how early career scientists can get into the space of interacting between science and policy. This has some excellent advice, which I'm hoping to take myself. One of the outcomes of the cyber moving more into interdisciplinary science is that some of the scientists have recently been granted a large-scale research program which looks at the interaction of people and their environment in the Indian Ocean. And I was really moved by this world map that was shown by Vladimir Ryabanin from the UN at the UN Decade of the Ocean Town Hall, which really shows the number of scientific papers per country. So that the world map is drawn from the abundance of papers that are published in science. And the thing that he pointed out is actually there is very little there from Africa. And this, I don't do this. And this resonated with the map that I put there up on Monday, where I showed that we were pleased with our geographical distribution, but there was quite obviously a long way to go, and particularly in the coastal countries in Africa. So I think you can see this week that IMBeR are really passionate about capacity building, and we're really, really proud of the IMACAN network, particularly the work of Chris Vitanovich and Steph and the team, the IMACAN Organizing Committee. But we need to think about now, what do we continue to do? What do we create? We're very innovative and creative in how we communicate our science to the general public. Let's use that innovation to think about ways in which we can communicate our science within ourselves. So, can we create masterclasses? Should we have targeted workshops? Should we have visiting lectures? Should we have mentors? So I'm thinking here of all of us learning, not just early career scientists. I've learned an incredible amount this week, and I want to learn more. Do we set up a network of national contacts? Do we create webinars, podcasts, or even a massive open online access course? So get your innovative, creative brains working there. How can we capacity build in a bigger, better way? So then, Grand Challenge 3, our experts, Derek and Ingrid, gave us some advice on what are the next steps. And Ingrid said that we really need, in order to achieve our good local and global ocean governance, we need to increase the number of trade-off decisions to be made. We need to understand how these trade-offs are made. We need to become more expert at using behavioral sciences to make these better collaborative decisions. And Derek suggested that we needed very important knowledge co-production. This was a catalyst to governance, and that we needed to think about governance being for transformative change. So I've already mentioned we want to try to measure our success. We want to try and reflect on where we are and how we can improve, how we can get better. You heard Alistair on Monday say that we should define what we think success is going to look like. And he proposed that success by 2025 would be that we could really say that we've provided information that underpins both protection and ongoing sustainable use of the marine environment. So this is something that we'll be talking about at our SSC on Saturday, is that just tomorrow? And one of the things we're trying to do is a case study with our IMBezos. We've seen that we have this series of 5 IMBezos. How have these impacted the marine community? And those of you out there that do this as your research, we'd really like to hear about mechanisms to evaluate how we're doing. So I tried to get some interaction through the app and asked, so what are the things that you think IMBeR can do to close some of these knowledge gaps? And you can see that we had a range of topics that perhaps we could have for interdisciplinary workshops in the future. So something that has come up in a lot of discussions of how to put humans into ecosystem models, how we design the quilt of ocean governance, how do we move to solutions? If this is not the community that's looking at how the impact of solutions, mitigation of climate change, if we're not the community that can interact the people and the social skills, the law, and the scientists, then which community can do that? So this is something that I learned from Eric this week. I think he said that we accept that all models are wrong, but perhaps the multi-model mean is not as wrong as a single mean. So what should I do then? I should look at what other networks and initiatives are doing as they progress towards sustainable science, sustainable ocean science. So these are 2 European-centric frameworks or recommended pathways towards ocean sustainability, and these are some of the recommendations that they suggest that we take up. So address critical gaps in knowledge, yes. Develop a new generation of ocean sustainability scientists, yes. Increase marine citizen science to drive changes in attitudes and behaviors. Is Celia in the audience? No, she's gone home. Okay, establish a sustainability science forum. So these are aligned with some of the things that we're suggesting to, which gives us more confidence that actually we're going in the right direction. And I hope that none of you are unaware that 2021 to 2030 will be the UN Decade of Ocean Science. So the General Assembly of the United Nations have called upon the Intergovernmental Oceanographic Commission to prepare an implementation plan for the decade in consultation with basically everyone. And we had a town hall on this UN Decade of the Ocean, I think on Wednesday or Thursday. So they have created an interim planning group and a vision for the decade, the science we need for the ocean we want. Great tagline. They have an executive planning group, and on that planning group is Karen Evans, who's the co-chair of ClearTop, IMBeR regional program, and they've set up a timescale of global and regional meetings between the first one occurred last month, and they have a work plan going forward to 2021. So we need to think about how IMBeR and the UN Decade of Ocean actually interact so that we can make a major contribution to this. So they are thinking, where are we now and where do we want to go next? So they're suggesting where we are now, that our science is largely competent for problems, for diagnosing problems, that our observing system is for climate-related information, and perhaps it's becoming a more emerging data service, that there are still major knowledge gaps and that ocean literacy is weak, that the funding base is mostly in research mode and that there's a hugely uneven capacity, especially in developing countries. And where do they want to be? Well, they want science to be providing solutions and motivating action. They want an ocean data system that's relevant and important for past, present, and future predictions. They need a globe of ocean literate people so that we can make well-informed decisions. There should be a clear value chain leading to resourcing and commitment. And this continual need, we need to capacity build. We need to be able to build a community of interdisciplinary scientists. So where do IMBeR want to go? What do we want to do? And I think we can tick most of these boxes. We want to improve the ocean data systems, we want to do science that provides solutions, and we really want to capacity build. So what's happening next? Well, we have a range of conferences, networking activities. There's the first IMBeR West Pacific Symposium in Thailand in 2020. Our IMBeR 06 we're going to discuss tomorrow. Where will it be? What will we focus on? Who is going to lead that? We're thinking perhaps that the next time we can do a Future Oceans conference will be about 2024. That will be close to when our science plan ends, so we can really review where we've got to. And one of the already planned annual science conferences for ESAS will be in Japan in 2020. So please get on board. I was really serious about needing this co-production, this community. Join the IMBeR mailing list. Let's go together. So in summary then, I think that our contribution to achieving ocean sustainability, I've seen a step change in data availability, including social science data. I've also seen a step change in real interdisciplinarity. I think IMBeR is in a strong position to link social and natural scientists and practitioners. And I really think we need to go forward with co-designing, co-producing, collaborating, capacity building, and being nice. Thank you.
Do we have any questions for Carol?
On the capacity development issue, there's real barriers to exchange and mobility of scientists, especially those from Africa, with increasing visa restrictions and lack of mobility targeted on certain countries, whether they're Islamic countries or African countries increasingly. What does the scientific community do about that when we have the goal of capacity development on the one hand, and yet on political level there are increasing restrictions to travel and communication in some cases?
Well, what we've started to do is asking people how we can help, rather than bringing everyone to a conference or a workshop. Can we be mobile? Can we go and start a network? Can we have a local contact who brings together people in that country? Can we use IT more often? And obviously everyone's a lot more technically au fait than me, but should we be producing podcasts? I mean, I like the idea of masterclasses. I like the idea of podcasts, of mentors. I would really like to learn more. I'm asking people, what can we do to help? We'll try our best to help.
Thank you, Carol. That was a wonderful lecture. I was wondering how you use or how you see IMBeR interacting with other groups that are trying to do very similar things. There's the Ocean Ops 19 conference in Hawaii this September that I think everybody should be aware of and try to get engaged in. There are many breakout sessions and many talks there that are essentially targeting the same things. So there's a lot of synergy, there's a lot of thinking globally on the same challenges that we're outlining in IMBeR. So how does IMBeR plan to engage with those various different groups, the Marine Biodiversity Observation Network and the IOC and the many different groups of the IOC that are planning these things, and not only Ocean Ops 19, but all the other professional society meetings that are coming up. So I think that there's a chance for synergy that I'm not quite sure how IMBeR can play.
Absolutely, and we try our best with that. We interact with Pisces, with ICES, with Goose. You know that you were headhunted and elected onto our scientific steering committee to be an interaction with IMBeR and ocean observations. I dare say, well, I know that a lot of us are co-authors on papers that have been published from Ocean Obs, and I'm sure a lot of us will be at that conference. We just need information. Obviously, it's silly to duplicate effort. We have to work together, which is exactly why we had this special session this week where Future Earth Coast, the Ocean Can, Earth System Governance, and IMBeR all came together, because it's completely daft us all doing things that duplicate. You know, we've only got so many hours in a day.
I think there's a question on the top row up there.
Thank you, Carol. I'm here.
Is that Marion?
Yes.
Hi.
First of all, I would like to thank the organizing committee. This has been a terrific meeting, and also you, Carol, because I have seen you rushing back and forth. And then I have a comment. I mean, I know in French we say I'm coming through an open door by saying this. We are doing our science in an existing socio-economical environment, and coming back on Doug's comment on the difficulty that we have, increasing difficulty in having mobility of people from certain countries. This is an increasing concern also to me, and it's not only about meetings, it's also about having people coming over on longer stays as a postdoc, as a PhD, or just, visiting on longer stays. So knowing this, we are in this political world, which is a personal statement, doesn't go into a direction I particularly fancy. That we are also in an economical world. And as scientists, we are working and thinking about ocean sustainability and blue growth. But I'm not the only one we discuss this among us, and who feeling a little bit, uneasy. Blue growth, sustainable use of the ocean, ecosystem value. Many things that have been good of the commons in the past and now have a tag of economical value with it. So we are in a liberal economy, but facing climate and also environmental change, we also have to question our way of doing science, our way of living. And I think we have a role to play there too. It's not only about blue growth. Perhaps we have to move towards a system where we accommodate and think about zero economical growth or very low growth. And what I'm scared about is that blue growth means growth rate as what we have seen in the past, and our world is a finite one. So I would just like to bring this out. I know that I'm not the only person thinking about this, but as scientists we have to echo this also. We are not just part of a system, saying we have models, we can put the society in, we can show you how it is possible to increase the income of this and this category out there by doing this and this to and with the ocean. We have to do more. We have to contribute to a change in society.
I entirely agree. I don't have the answer of how we do that, but I entirely agree. And I think we need to talk about it. And I see all these challenges, but I've been brought up, where there's a will, there's a way. If at first you don't succeed, then you try again. And I think if there's enough of us, then if the UN Decade of the Ocean is saying these are the things that really need to happen, then gradually, together, we'll make them happen.
Is that the question up there?
Yeah, well, thanks for a very interesting conference and with a lot of interesting discussions. There are several threats to the marine environment that were not really much discussed at this conference. And I know that there are other, of course, conferences that deal with those issues. And but I think maybe there should be at least some more wider presentations that include things like plastics, which is going to be a huge problem in a few years. Industrial development, deep sea drilling or deep sea exploitation of whatever. And we talked a lot about climate change, a lot about ocean acidification, but very little about these big changes that actually will happen to our oceans in a few years. So maybe we should think about how to better integrate and present some of those in the IMBeR setting.
Yes, it's true. Though after being chair of IMBeR for 3 years, the criticisms I always get is that IMBeR's too big, that people cannot get their heads around it. So when we wrote the science plan, our reviewers gave us lots of new ideas, and we said, for the amount of money that we have, we cannot do everything. We have to work with partners to do this. And so obviously plastic is really important, and there's lots of other stresses that are really important. In terms of meeting our science plan, then some of the things we had to leave out because we couldn't achieve. But our conferences and our meetings, suggest a session, see if we can get a session running up on some of the other stresses that you worry about. Yeah.
Any other questions? I can't It's quite hard to see at the top row because of the light. Any other questions? Okay, well, thank you very much, Carol, for a great talk.
You're very welcome.